In this video, we will discuss how to get the length of a vector and solve the distance and angles between vectors. The length or norm of a vector, which is denoted by this symbol, is equal to the square root of the sum of the squared components of the vector. Like a dot product, the length of a vector is a scalar, not a vector. A vector of length 1 is called a unit vector. In R2, the set of all vectors can be identified with a unit circle, the circle of radius 1 centered at the origin. Given any non-zero vector, we can always find a unit vector in the same direction as v by dividing the vector by its own length. This process is often referred to as normalizing a vector. For instance, let's have example 1.10. We are asked to draw the vector u, which is equal to 2 and 3, in a Cartesian plane and find its length, then we normalize it afterwards. We first draw the vector in the Cartesian plane by counting 2 units to the right and 3 units upward. 2, 3. From there, we draw the head of the vector and connect it to the origin for its tail. The length of the vector is the square root of 2 squared plus 3 squared, which is equal to the square root of 4 plus 9, which is equal to square root of 13, or about 3.61. Notice that this process is the same with using the Pythagorean theorem, wherein we identify the x-coordinate, which is 2 units, and the y-coordinate, which is 3 units. To normalize the vector, we divide the vector by its length. Or in other words, we multiply the reciprocal of the length of the vector, which is square root of 13. So the reciprocal is 1 over square root of 13. And our vector, which is 2, 3. This is equal to 2 over square root of 13 and 3 over square root of 13. Simplifying the expression gives us 2 square root of 13 over 13 and 3 square root of 13 over 13. Let's consider example 1.11. Again, we are asked to find the length of the vector u, then we are asked to normalize it afterwards. So to identify the length of the vector u, we use the formula length of u, or norm of u, is equal to the square root of 1 squared, that's the first component, plus 3 squared, that's the second component, plus negative 2 squared, which is the last component. We perform the operation inside the square root. We have 1 plus 9 plus 4. Getting the sum of all the numbers inside the square root, we get 14. To normalize the vector, we multiply the vector by the reciprocal of its length. This gives us the following components: 1 over square root of 14, 3 over square root of 14, and negative 2 over square root of 14. Now we will try to simplify this one by rationalizing each expression. So this is equivalent to square root of 14 over 14. This is equivalent to 3 square root of 14 over 14. And this is equivalent to negative square root of 14 over 7. Which gives us the final answer. Similar to dot products, this operation has some properties. The first property is that the length of a vector is 0 if and only if it is a zero vector. Also, the length of the product of a scalar and a vector is just equal to the product of the absolute value of the scalar times the length of the vector. Let's try to check if you know how to identify the length and normalize a vector. You may pause the video and answer the following. Find the length of vector v, which components are 4, 2, and 5. Then normalize it. The length of the vector v is equal to the square root of 4 squared plus 2 squared plus 5 squared, which is equivalent to 16 plus 4 plus 25. Adding all these components here, this is equivalent to square root of 45, which is equivalent to 3 square root of 5, or about 6.71. To normalize the vector, we multiply the vector by the reciprocal of its length. And that is 1 over 3 square root of 5 times the vector 4 to 5. We perform the operation and get the following components. 4 over 3 square root of 5, 2 over 3 square root of 5, and 5 over 3 square root of 5. Rationalizing each components, we get 4 square root of 5 over 15, 2 square root of 5 over 15, and square root of 5 over 3. To get the distance between two vectors, we simply get the length of the difference between the two vectors. For example, let's consider example 1.12. We are asked to draw vectors u and v in a Cartesian plane and find the distance between the two vectors. So let's try to draw vector u. So we count 2 units to the right and 3 units upward. So it's somewhere here. Then we draw the vector. So this is vector u. And for vector v, it's -1. So we count 1 unit to the left and 4 units upward. After, we connect this to the origin and draw an arrowhead. So this is vector v. Now we are asked to find the distance between the two vectors. To do that, we first get the difference of the two vectors. And this is equal to 2 minus -1 and 3 minus 4. Performing the operation, we get 3, -1. After we get the difference between the two vectors, we get the norm of the new vector. So I will write this one as a row vector. So the norm of this vector is the square root of 3 squared plus negative 1 squared. And this is equivalent to square root of 9 plus 1, which is equal to square root of 10, or around 3.16 units. Notice that the process is the same with getting the distance between 2 points in geometry. Let's have another example. Find the distance between vector u and vector v. Which components are stated? Again, the first step is to get the difference of the two vectors. And that is square root of 2 minus 0, 1 minus 2, and negative 1 minus negative 2. Performing the operation, we get the new vector, square root of 2, negative 1, and positive 1. Next, we get the norm of this new vector, which is equal to the square root of 2 squared plus negative 1 squared plus 1 squared, which is equal to the square root of 2 plus 1 plus 1, which is equal to 4 or positive 2. Let's try to check if you know how to solve for the distance between two vectors. You may pause the video and answer the following. Find the distance between vector u and vector v. To find the distance between the two vectors, the first thing that we need to do is to get the difference between the two vectors, which is 3 minus negative 1, negative 2 minus 0, 5 minus 2. We perform the operation and get the new vector, and that is 4, negative 2, and 3. Now, we get the norm of the new vector, which is equal to the square root of 4 squared plus negative 2 squared plus 3 squared. Performing the operation, we have 16 plus 4 plus 9. Adding all this, we have 29, square root of 29. And we cannot simplify this one, so we can have it. To solve the angle between two vectors u and v, we use the formula cosine theta is equal to the dot product of u and v divided by the product of the length of the two vectors. Let's have an example. Let's compute the angles between vectors u and v. To do that, we need to solve first the dot product of u and v. Which is equal to 2 times 1 plus 1 times 1 plus negative 2 times 1. This is equal to 2 plus 1 minus 2, which is equal to 1. Next, we get the norm of vector u, which is equal to the square root of 2 squared plus 1 squared plus negative 2 squared. This is equal to square root of 4 plus 1 plus 4. And we get square root of 9, which is equal to 3. Next, we identify or solve the norm of vector v, and that is equal to the square root of 1 squared plus 1 squared plus 1 squared, which is equal to square root of 1 plus 1 plus 1, or square root of 3. Now we were able to solve for all the components needed to identify the angle between the two vectors. We will use now the calculator. So to identify the theta with the cosine function, we use shift cos to access the arc cosine function. Then for our numerator, that is the dot product of the two vectors, which is equivalent to 1. And for our denominator, we need to multiply the norm of u, which is equal to 3, and the norm of vector v, which is equal to square root of 3. Make sure that your calculator is in degree format, because if this one is in radian, we will have a different result. Press equal sign and you will have the result, which is theta is equal to around 78.90 degrees. Let's consider another example. Again, we are asked to compute the angle between the two vectors, u and v. So the first thing that we need to do is to get the dot product of the two vectors. So the dot product is 3 times 4 plus 4 times 3. And this is equal to 12 plus 12, or 24. Next, we get the norm of vector u, and that is equivalent to the square root of 3 squared plus 4 squared. So this is equal to square root of 9 plus 16, which is equal to square root of 25, or 5. Next, we get the norm of v, and that is square root of 4 squared plus 3 squared, which is the same. That is 16 plus 9, and still equal to square root of 25, or 5. So let's try to identify the value of the theta using the cosine function. So our numerator is 24, whereas our denominator is 5 times 5, or 25. We now use our calculator to solve for the theta. So we press shift cosine, then we indicate the numerator, that is 24, and our denominator, that is 25. Therefore, the angle between the two vectors is around 16.26. Don't forget to write the unit measure. So let's try if you were able to understand the concept or the process in getting the angle between two vectors. You may pause the video if you need more time. Here we are asked to find the angle between the vectors u and v. So in this example, I will try to solve this one right away using the calculator. So to do that, I'll press shift cosine to access the arc cosine function. Then we use this one, box over box, to have the fraction. So for the numerator, we solve for the dot product of vectors u and v. So that is equivalent to 2 times negative 1 plus 5 times 6 plus 6 times 2. So that's the dot product. Next, in the denominator, we solve for the norm of vector u. So we use square root of 2 squared plus 5 squared plus 6 squared. We move forward and have the multiplication sign. Then another square root for the norm of vector v. So that is -1 squared plus 6 squared plus 2 squared. Hitting the equal sign, and we will have the result, which is around 39.21 degrees. That's how you solve for the length, distance, and angles between two vectors. Good luck and have a good day.